So far, all of our analyses have started with a data frame, one row per observation, one column for each attribute. But let's say you have just one vector of numbers and you want to create a histogram, or you have two vectors and you want to make a scatter plot. It may not be worth it to construct a data frame with those values just so you can graph it. To make your life easier, ggplot2 provides a simple way to plot one or two vectors, which is the qplot function. Let's generate some random numbers we want to plot. The rnorm function generates random values from a normal distribution or bell curve. So if we create a variable x equals rnorm, and we say how many values we want, for example, 1,000, we created a variable that contains 1,000 values. Here we can see each of these values was drawn from a normal distribution. Let's say we want to histogram these values. We can give them to the function qplot of x. This creates a histogram without having to manually create a data frame or specify a geom histogram. The shortcut also lets us set options easily. For example, we can change the bin width of the histogram by giving the bin width argument to qplot. Bin width equals 1. We can also set the x and y axis labels easily. We can do that either by adding the xlab and ylab options like we did before. For example, qplot plus xlab, and then our custom x-axis label. Or we can add the xlab argument to the qplot function. Histograms aren't the only thing we can create with qplot. Let's create a y variable so that we can construct a scatter plot comparing x to y. We'll make y also be a random normal distribution. So y equals rnorm 1,000 values. If we want to scatter plot x versus y, we can simply give both of them to qplot. Note that we can still add layers to this basic plot just like we could to a regular ggplot call. For example, we could add a smoothing curve with the geom_smooth layer. This layer ends up on top of the regular scatter plot that's created by qplot. Now, so far, we've been working with the built-in diamonds dataset. Those plots were really easy because the data were given in the format of one observation per row, that is, one diamond per row, which we call tall format. But many datasets come in a wide format. That means there's more than one observation, more than one point on your scatter plot in each row. For example, let's look at the world phones dataset, which comes built into R. So just like we did for diamonds, we're going to use data of world phones to load it. You can see it got added to our global environment. You can view it using the view function. You can also get more information about world phones using the help function. This dataset shows the number of telephones, measured in thousands, in each continent in each of several years in the 1950s. Notice that each column is one continent, and each row is 1 year. Now that sounds like a reasonable way to store your data, but imagine if we want to compare increases in phone usage between continents with time on the x-axis. That means each point in our plot is going to be one continent in 1 year. We don't have one observation per row, we have 7, and that makes it very difficult to plot it using ggplot2. Luckily, there's an easy way to turn this into tall format, which is called melting the data. To do this, we'll have to install another third-party package called reshape2. Recall that you can do this with install.packages "reshape2", just like we did with ggplot2. So now we load the reshape package, just like we did with ggplot2, library reshape2. And now we can melt our data set, that is, turn it from this wide format, many observations per row, to a tall format, one observation per row. Let's assign the new melted data to a variable called worldphones.m, m for melted, equals melt. We're using the melt function on the world phones data. Now let's view this new melted world phones m. Notice that there are now only 3 columns, var1, var2, and value. So var1 is year, var2 we see each of the continents, and var3 is the number of phones. What happened is that every cell, every observation, every number of phones per year per continent in its original data got its own row in this melted data. We can see that in the year 1951, in North America, there were 45,939,000 phones. You can see the same value in our original melted data. So none of the data changed, it just got reshaped. To make the data a little more intuitive, you can change the column names. You might recall that we could do this as follows. Call names of worldphones.m equals then our vector. We have quote year, continent, and phones. So now if we view worldphones.m, we can see our new column names. Now that we have our data in melted format, it's easy to create a plot with ggplot2. We go through our usual steps of a ggplot call, but this time give it worldphones.m. We do ggplot worldphones.m AES. On the x-axis, we're going to put the year so we can see how things change over time. On the y-axis, we want to put the number of phones, the quantity we're interested in graphing. And let's color each point based on the factor of continent. Then we'll add the geom_point layer to make this into a scatter plot. And we've worked with scatter plots before, but in this case, what we're showing is a trend over time. It might be better to draw lines between the points in a continent. This is easy. We can just change the layer to the geom_line layer. Now we have a plot of the number of phones in each continent by year. Incidentally, one might expect phone service to increase exponentially rather than linearly. Also, a lot of the values here are really scrunched up in the bottom of the axis. When that's the case, it's a good idea to put the y-axis on a log scale. Recall that we can do that by adding scale_y_log10 parentheses. Now each of the phone trends looks linear, and we can see the lower values more clearly. For example, that Africa overtook Central America in the number of phones in the year 1956. Notice how easy this plot was to make once we had the data in the correct format. One row for every point, that's every combination of year and continent on our graph. So if your data is not in that format when you're starting out, melt it.